So in this video, we're going to look at a related rates example applied to a flying airplane. So here's the example. It says an airplane is flying at 500 miles per hour at an altitude of 3 miles directly away from a radar tracking station. How fast is the plane's distance from the tracking station increasing at the moment the plane is directly over a point 4 miles from the tracking station? So let's say that the tracking station's right here. So the radar tracking station's here. And the plane is flying at an altitude of 300 miles directly away from that tracking station. So at any given point, the plane is going to be on a horizontal horizontal path that's 3 miles above the ground. So let's suppose that the plane is right here. And what we're being asked to find is the rate at which the distance from the plane to the tracking station is increasing. So if I draw in a line there, I'm being asked to find when or how fast this distance, the distance from the plane to the tracking station, is changing. What I know is that the altitude of the plane is a constant. We're given that it's flying at a height of 3 miles above the ground. This ground distance right here is going to be changing. So I'll label it with an X. It's changing. And the distance from the plane to the tracking station is just the hypotenuse of this right triangle. So right away I see that I could describe the distance between the plane and the tracking station using the Pythagorean theorem. The distance, the length of that hypotenuse, is going to be a function of x. And by the Pythagorean theorem, it's going to be the square root of x squared plus 3 squared, or just x squared. I said 3 squared, and it doesn't look like I wrote it. X squared plus 9 to the half. So the distance as a function of x that the plane is from the tracking station by the Pythagorean theorem is going to be this. And then we're asked to find the rate of change at a specific point in time, the point in time when the plane is exactly 4 miles ground distance from the tracking station. So the plane is directly over a point that is 4 miles from the tracking station. So we're being asked to look at the point in time when the distance x is equal to 4 miles. When the distance is 4 miles, I can calculate the distance the plane is from the tracking station using the Pythagorean theorem here. I can say, hey, when the ground distance is 4 miles down here, that's just going to be h of 4, which is going to be 4 squared plus 3 squared. Square root of that's going to be the square root of 25, which is just going to be 5. So when x is 4, by the Pythagorean theorem, h is 5. It's a 3, 4, 5 Pythagorean triple. And the distance x is changing. I actually know dx dt because the ground distance, if the plane's flying at 500 miles per hour, then the distance from the tracking station to the point directly below the plane is going to be changing at 500 miles per hour as well. So I know that dx dt is equal to 500 miles per hour. So if I want to know the speed at which the distance from the plane to the tracking station is changing, I need to calculate dh dt. And I want to recognize that dh dt is going to, because I have h described as a function of x, it's going to be dh dx, and then I'm going to need to multiply by dx dt to get dh dt. So I need to take the derivative with respect to x. So I'm going to do that here. I'm going to get 1/2 x squared plus 9, subtract 1 from that exponent. Now I have a function inside of the square root function, so the chain rule says take the derivative of the inside function, which is twice x. So this piece here is my dh dx, and I need to multiply that by dx dt. There's the implicit differentiation piece to get my multiply it by dx dt to get my dh dt. And now I can simplify things here just a little bit. I get 1/2 of a 2 is going to be 1, so I just get 1x over, and the negative exponent can be dropped down into the denominator if I want. So I can do x squared plus 9 to the positive half in the denominator, and times the dx dt. So when x is equal to 4, if I want to know dh dt when x equals 4, it's just a matter of popping the pieces in now. So we get, when x is 4, we get the square root of 4 squared plus 9, which is the 5, times dx dt, which is 500. So we get 4/5 of 500, which is just going to be 400 miles per hour.